Okay, we're going to talk about vectors, and we're going to talk about adding them together. Because as we get into unbalanced forces, we need to understand how to combine vectors together to find out if the forces that are acting on an object are balanced or unbalanced. And they're not always going to be exactly perpendicular or parallel to each other at these 90-degree angles. And I want to make sure you understand how to add vectors together to find what we call the resultant vector when they aren't perpendicular to each other. And I'm going to start off with a simple example where they will be perpendicular to each other, and that is when you're walking in your neighborhood. Let's say you walk a couple blocks north from your house. Okay, so your house is down here at the base of this arrow, and I just went 2 blocks north. Then you take a right on the next street, and you go a block to the right, and then you go north again for a couple more blocks. I probably need to lengthen that a little bit. Make this a little bit longer. If I can. There we go. All right, so now I want to know what my displacement is from the beginning to the end of this little journey that I just took. And all I have to do is draw a vector from the beginning point to the end point. And you can see that the distance traveled, the distance traveled is the length, or the displacement vector is the blue vector from beginning to end. So that represents the combination of those 3 vectors that are shown in red. What if I have, let's say, a bunch of force vectors? It's really easy to find the unbalanced force when my vectors all look like this. When I've got one up, one down. Here, let me scoot down a little bit so you can see this. And I've got one to the left and a shorter one to the right. Let's say these 2 are congruent. It's obvious that I've got an unbalanced force to the right of, I don't know, looks like it's about this long. There's a little unbalanced force to the right. If I subtracted the length of that arrow going to the left from the length of the arrow going to the right, I probably have that much left over. So there's an unbalanced force of qualitatively that's about that long. But what happens if I have a bunch of vectors at different angles? In other words, I'm trying to figure out if these 2 vectors here, those 2 vectors there cancel each other out. Well, it's very hard to figure that out. Actually, you know what I'm going to do? I'm going to do this on another page, and I'm going to use the arrow tool here. All right. So let's say I've got a vector going up here. It's just going to be a little more precise. And then I've got a second one that is going down at an angle like this. Let's say I want to keep it on my page there. There we go, like that. And I want to figure out if these 2 vectors that are acting on an object, what the balanced or what the result is of combining these 2 to figure out if it's balanced or unbalanced. Well, obviously neither one of these are perpendicular to each other. They're not parallel, so I can't just simply look at the lengths of them and say they cancel out because they're going in different directions. What I have to do in this case is I have to find the x and the y components, the horizontal and the vertical components, and then I can tell if there's a net force or an unbalanced force in either the x or the y direction, or maybe both. So what we're going to do is we're actually going to find the component vectors here. I'll make them dashed. All right. So this component vector is going to look like that for the y, and this one is going to look, drew it the wrong way. This one's going to look like that in the x direction. And then for the other guy, it's going to be, there's the x component and there's the y component. So let's give these things some names. I'm going to call this one F1. I'm going to call this F1y, and I'll call this F1x. And I'm going to call this guy over here F2, and so this would be F2x, and F2y. Okay, sorry, I'm off the page a little bit there. So what I'm going to do is I'm going to combine f1y and f2y and f1x and f2x to figure out what my resultant vector is. That's what we call the combination of two vectors. It's the resultant. So it's kind of the result of adding two vectors. And I don't have any numbers associated with these, but you can kind of tell if I pick this guy up, there's a little bit extra. If I lay it, if I lay it side by side with the red vector in the y direction going down, there's just a little bit extra left over at the top here of the y vector going up. So I know there's a little bit of an unbalanced force going up in the y direction. And in the x direction, it looks like I'm going to have a little bit leftover force going to the left, just that little tip of the red vector there left over. So I know I'm not using numbers here, but I can tell I've got, let's make our resultant vector. I'll make it on the next page. It looked like I had a little bit of a leftover y vector in that direction, and it looked like I had a little bit leftover x vector to the left. Okay, so actually what I would do is I would put those end to end, actually tip to tail like that. Doesn't matter how I arrange them, if I do the red one on the end of the blue vector or the blue one on the end of the red vector, but my resultant vector is going to be just like I showed you at the beginning with that the displacements. Sorry about that. I'm just going to connect the beginning of the first vector with the end of the second. So like this. That's my resultant vector. So in the last step of this process, assuming that I am actually using numbers, let's call the red side A, and let's call the blue side B, okay? It's going to be just that you'd expect a squared plus b squared equals c squared. You can use the Pythagorean theorem to get the length of that side C right there, okay? And you're going to find the direction of that vector based on the inverse tangent, okay, of this little tiny angle that's in here, okay? That little guy that's right there. So you're going to do an inverse tangent of, I guess it would be opposite over adjacent. A over B would give you the magnitude. Oops, I did that off the screen. It's on my screen of my iPad. So that's how you would find the magnitude and the direction of that resultant vector. So again, all we did is we found the components. We combined the y components. I had one going in the positive direction, one going in the negative direction. You'll actually use numbers here, so you won't have to lay them side by side like I did. You'll actually have a number for the size of this side, and you'll have a number for the size of this side, and you'll be able to calculate an actual number for these. So hopefully that makes sense to you. If you have any questions, by all means, bring them up in class and we'll discuss them. Okay? Have a great afternoon.